Hi, this is Mrs. Lyons. This PowerPoint is on naming and writing formulas for compounds containing polyatomic ions. So these are going to be ionic compounds. They have a cation and an anion, but there's going to be a polyatomic ion in the compound. And the way that we deal with polyatomic ions, you don't have to memorize them. You have your polyatomic ion chart on the back of your periodic table, and it lists, for example, it might say NO3 minus, and then it tells you that this is called a nitrate ion. Okay, so what we're going to do is we're going to use that information to start including the names and the formulas for things with these polyatomic ions. What nitrate is it's one nitrogen, three oxygens, and that whole thing combined has a -1 charge. Okay, so let's take a look at what we need to be able to do with these. The first thing we need to be able to do is to name compounds containing polyatomic ions. So the way we do that, we name the cation, which is the metal, or a polyatomic ion. We look and we see if it's a metal, or if it's got more than one atom in it, it would be something polyatomic from our polyatomic ion chart. Then we're going to name the anion. That's either going to be a nonmetal or a polyatomic ion. If it's a nonmetal, and only if it's a nonmetal, we change the ending to IDE. Polyatomic ions, the endings stay what they are on your polyatomic ion chart. So let's look at some practice problems. First problem, Ca parentheses NO3 parentheses 2. Okay, so we should recognize Ca as calcium. So we're going to write down calcium. And then we're going to look at what is inside parentheses only. So NO3. Look at your polyatomic ion chart. Find NO3. You'll notice it has a -1 charge, but the name is what we're concerned with. The name is nitrate. Whoops. Nitrate. And so the name of Ca parentheses NO3 is calcium nitrate. All right, let's look at example number 2. Li. We should recognize this as lithium. And then we're going to look on our polyatomic ion chart. We're going to find SO3. It's not in parentheses, so the whole polyatomic ion is this SO3. If we look, we're going to find out that that is called sulfite. So our compound name is lithium sulfite. Example number 3, Ba. We know that Ba is barium. And then inside the parentheses, we see we've got ClO. Okay, don't confuse this with an I. A lot of people see this as CiO3. It's Cl, chlorine, and oxygen. And if we look at our polyatomic ion chart, ClO2 is chlorite. So barium chlorite is our name. Finally, our fourth example, we have NH4Cl. Now, notice that N is not a metal. That should be your first clue. Since this doesn't start with a metal, what we're going to look at is this NH4. If you look on your polyatomic ion chart, NH4 is called the ammonium ion. So we're going to write down ammonium. Then we have Cl. Since this is a non-metal, we're going to change the ending, since it's a single element, to chloride. So ammonium chloride is the name of that compound. Next, we need to write formulas. If we're given a name, we need to write the formula. So we're going to write the atom or polyatomic ion and the charge, just like we did in writing formulas for polyatomic ions. We're going to crisscross our charges again, drop the positive or negative sign, and simplify if we need to. So, excuse me, so let's look at some examples. We have potassium nitrite. So we look at our periodic table, we find potassium. It's in group 1. We know that it has a +1 charge. If we look at our polyatomic ion chart for nitrite, notice an ITE ending. We find nitrite is NO2. it's got a -1 charge. So we're going to crisscross our charges down. Since they're ones, we don't have to write them. So this is simply going to be KNO2. Since we don't have anything, a number outside of the parentheses, we don't need the parentheses. Second example, barium phosphate. Barium is Ba. It's in group 2, so it's got a +2 charge. Phosphate, look at your polyatomic ion chart. Phosphate, ATE ending, that's the clue. Phosphate is PO4. That whole thing has a -3 charge. So we're going to crisscross our charges. We're going to take this down outside of the parentheses. We're going to take this down. Our final compound formula is Ba3. We have to put parentheses, PO4 parentheses 2. So there's 2 phosphate ions and 3 barium ions in that compound. Ba3 parentheses PO4 parentheses 2. Aluminum hypochlorite. So we know aluminum is Al. If you look at your periodic table, it's got a +3 charge. Hypochlorite, again, no IDE ending. This is our clue to look at the polyatomic ion chart. ITE ending, hypochlorite is ClO. It's got a -1 charge. So we're going to crisscross. We're going to bring the 3 down here, the 1 down here. Our compound is Al. Since it's a 1, we don't have to write it. ClO parentheses 3. We have to include the parentheses because that's telling us we have 3 chlorines and 3 oxygens. The 3 is like a multiplier for everything inside the parentheses. A couple more practice. Magnesium sulfite. So we know that magnesium is Mg. It's got a +2 charge. Sulfite, ITE ending, that's a polyatomic ion. Look at your polyatomic ion chart. Sulfite is SO3 with a -2 charge. We crisscross our charges down. We get Mg2 parentheses SO3 parentheses 2. Now notice that we have a 2 here and a 2 here, so we can simplify. Okay, the number has to be outside of the parentheses in order to simplify. We can divide both by 2 and we get MgSO3. Last one, we have ammonium phosphate. Remember, ammonium is that one positive ion, and it is NH4 with a +1 charge. Phosphite is PO3 with a -3 charge. We're going to crisscross our charges outside of the parentheses. We never change anything inside of the parentheses. So our compound is going to be NH4 parentheses 3. Since the 1 goes outside the phosphite, we don't need the parentheses, so PO3. That is your final compound formula. 2 more examples. Sorry, I forgot I had 2 more. Ammonium carbonate. So ammonium is NH4 with a +1 charge. Carbonate is CO3 with a -2 charge. We're going to crisscross. We get NH4 2 CO3. That one has 2 polyatomic ions in it, so that one's a little bit tricky. But you just look at the names, do it just like a regular ion. Last one, aluminum phosphite. Al is +3. Phosphite from your polyatomic ion chart is PO3 -3. We're going to crisscross our charges down. We get Al3 parentheses PO3 parentheses 3. Notice we've got 2 3's, so we have to simplify to AlPO3. Alright, so that's formula writing and naming for ions, or for compounds containing polyatomic ions. Hope that helps. See you soon.